Hello. So this will just be a quick video talking about how you can use Geantino for confirming your geometry instead of using visualization. So let's set like regularly, if you just wanted to look at a simple geometry, we just view it in interactive mode with visualization enabled. So in this case, I've got a 1 meter cubed air volume representing the white, and then I've got this water cube or water phantom 30 centimeter cubed in the middle. And if I just wanted to confirm that it's looking all right, I'll just pop up this visualization. But this visualization in fact might be a bit off. I don't know, let's say it was like shifted a few centimeters, but it looked more or less correct just on this quick visualization. Or let's say even worse, you just haven't got access to visualization. And in that case, using a Geantino is the next best thing, and in many cases better because it gives you precise information about the position. So to do that, we just need to shoot a Geantino, and if I open up run Geantino macro, then if I look at starting position, I've already got it set up to be the correct position. And actually, since I just want to debug geometry, let's just make it a point beam instead of this square beam of 10 by 10 centimeters. So for this, I'll just make it just 0 in area. So I've got it starting at -50. So let's just quickly visualize again. And so let's just drag this over here for the time being. And so our starting position is -50 centimeters. So in the Z, so one of these directions, and then it's going in the positive Z direction. So this direction is the initial momentum of the beam. So XYZ, so 0, 0, and +1. So it's starting from here. Let's just say this is the Z direction. So it's going -50 in the positive Z to, and it'll stop eventually at the, when it reaches the world boundary, so at +50 centimeters. And then because it's a Geantino, which is a fake particle, which only interacts with boundaries of geometries, and so this energy doesn't really matter, but it's defined regardless. So let's just close that down, and just we're going to run this Geantino macro now. So, oh yeah, I changed it to 0 there. So let's just run the macro in batch mode. So sim, then run geantino.mac, and I've got tracking verbose set to 1. So I'll see all this output, and let's just make that slightly smaller. Just run again. And so if you didn't see this track information, and just be because your verbose wasn't set to 1, it was probably set to 0 instead. And if it still doesn't appear, then either you haven't got any particles being shot, so run beam on should be at least 1. Otherwise, you might be editing the original version of the macro outside of the build directory. So remember, when you make your build directory and do the cmake, it copies the files in this directory here, the macros, so all the .mac.c files, and just copies them as they are in the edepsim directory, and just put them in the build. So these are the actual macros which you're running when you're running the program. So just be careful you're not editing the ones in the edepsim directory in here. Otherwise, they won't be the changes won't be taking effect. So looking at the output of our running our Geantino, so we see it starts at -500 millimeters in the Z and 0, 0 in the X and Y. And energy doesn't matter, but this is where it's starting, because it hasn't moved anywhere. It's step length 0 because it's just been created there. Track length 0 hasn't, because it's just been created. We see it's in the physical world, and then if we go to the next step, then we see it's now reached minus 150 millimeters in the Z, and this makes sense. Well, yeah, because our cube we wanted was a 300 millimeter cubed cube, so we're expecting it to start at minus 150 millimeters and to end at positive 150 millimeters in the Z direction, and in fact all the directions. So as I said, the first step from the minus Z direction into the 150, and if we look at the step length, the distance from the world to the start, or this face of the phantom in this arbitrary direction, it was 350 millimeters. So just another sanity check. So half of the world is 50 centimeters, 500 millimeters, because it's meter in total. So 500 minus 150, then 400, 350. So yep, that's also what we expect. And so that was the distance from the start of the particle to the start of the phantom, and track length is running total. And then if we go to that second step, so this should be where it reaches the end of the phantom and the start of the air again, so positive 150, and the step length between those two phantom Z positions was 300, again what we expect because we wanted a 300 millimeter cubed, and step length is 650 because this is a running total of how far this track or particle has traveled. And so once we've reached at 150, we then go back into the air, and then that's another 500 millimeters to go to the another 500 millimeters. So at 500 millimeters is where the next step occurs, which is the end of the world. So that's where the particle stops being tracked because it leaves the world. And then it was another 350 millimeters to reach from the phantom to the world, and in total it's 1 meter. So everything as we expected. And if we wanted to be pedantic, we could change and look at a different direction. So let's say we now want to go in the X direction instead of the Z direction, just to make sure. And we'll do it like this for starters. So now I've just changed it from the starting from minus 50 centimeters in the Z to minus 50 in the X, and I'm now going the positive X direction. So if we run that, we should now see the X having the changes in the step value. So again, we see the same output, minus 50, and then the next position's minus 150 and positive 150. So the water phantom seems to be symmetrically placed as we wanted, but if we didn't have the phantom placed correctly, then maybe we would just see this physical world and outer world. But because we have these steps of physical phantom, then we know we've placed our phantom somewhere at least, and luckily we have the expected outputs. And I'm just quickly going to change the viz.mac and just show the tracking with the actual, visualize the Geantino and just the corresponding position. So currently, what have I got here? I've just got a proton. So actually, let's just copy all this Geantino and put in this viz.mac. And currently I'm in the Z from before. So let's just change it back to the original Z direction. Save that. Good. So after we've changed the viz.mac, which is the default macro which runs automatically when we run in interactive mode, so we just go /edapsim and let the pop up. So now we've got the we've entered the Geantino locations in the viz.mac, then all these settings will be loaded into the simulation. So if we actually run the beam now, so run beam on 1, then we'll actually have all the Geantino starting and ending positions loaded in already. So we can now compare the step location and just see it visually of what it's doing. So it starts here, minus 500Z, and just ignore that offset of the columns. The formatting is not the most accurate all the time, just in terms of, maybe not accurate, just not the clearest, because, got that shift in the output. But anyway, so we've got our particle starting at minus 150, so here, and then if you zoom in far enough, we should see a yellow dot, which, it's very hard to see. Let me just change to move mode. And if you look very closely around this, maybe you'll see this very faint yellow, which I thought I did see it, but then I lost it. But yeah, where this step occurs here at step 1 is where a yellow dot would be from this boundary of the air and the water, or the world and the phantom. And so, and just to give some context of these volume names, so these volumes relate, as the heading says, the next volume. So the particle starts in the world, and the next volume says the physical world, and that's this boundary here. So with Geant4, remember, when the particle's tracking, it forces a step wherever there's a volume boundary, and that's just got to do because it has to calculate various cross sections of interactions based on the material it's in. So whenever there's a boundary, and I was going to, let me just rotate. This might be slightly easier to talk about. If I was smart, I would just use the set theta phi command in the prompt, but this will do. So I was talking about the next volume. So, and with Geant4, every time there's a boundary of volumes, it forces a step or an interaction. So particle starts in this world, and when it gets to this boundary, this volume boundary, it forces a step, and that's just got to do because of cross sections have to be calculated based on the material it's in. So whenever there's a boundary here, it forces a step there, and at this step here, so at step 1 is when it's, so step 0, when it's created, and then the next step 1, it is transitioning from the air to the water. So at step 1, it's still in the physical world because at step 0, the next volume is physical world. Then at step 1, it's stopped at the world / phantom / air water boundary, and the next volume will then be the physical phantom because it stopped at the boundary between the world and the phantom, and so the next volume will then be the world, and then once it gets to here, at the end of the phantom, the next volume is just then the world again, but the particle has to stop here at the volume's boundary, just because, again, the cross sections for the certain material have to be calculated, needs to be calculated for that material it's in. Otherwise, it will just give silly calculations. And then finally, when the particle Geantino reaches the end of the world boundary, it's got nowhere else to go. So then says the next volume is out of world. And that's just a bit of a breakdown of the comparing the visual track with the actual output of the track. So hopefully that tangent on the boundary and forcing steps wasn't too out there, but just to summarize the main point of this video. So, if you can't visualize, or even if you can visualize, it's very handy to validate or confirm your geometry by running a Geantino and just setting it in a simple direction. And once you do that, you'll be able to determine the precise location of the geometry you place, or whether you've actually placed it. So, and for instance, it's a very simple geometry, but if it was more complex, then it might look fine, but it might be off slightly by a few millimeters if you're placing lots of different volumes. So it's always handy to shoot a Geantino to confirm your geometry. And if you don't have visualization available to you, then it's very, very important / borderline essential. All right, that's all I wanted to talk about.